Hi, good evening. Today we're doing C++ Huffman compression algorithms. Um, Huffman algorithm has a complexity of O bracket 1, right? It is used in file compression. So .zips, .gz, .rar formats use Huffman as a compressor. Um, you use it in multimedia formats like JPEG, PNG, pictures, right? MP3s. I mean, they use it for encoding the residuals there. It's also used for text compression when you compress documents into gzip files and bzip2 files. So you can use it there. It can be used for data transmission. It reduces the bandwidth when you're sending encoded messages across a network, so it can be used for optimization. It is used in optimization of messages. Compilers, when you build them out, you can use it there, and it is very useful in embedded systems because it reduces memory usage for dictionaries, which are hash maps, and for messaging back and forth again with the compression for data transmission, right? Because messaging is data transmission. Um, anyway, so that's the use of this algorithm. Uh, how it really works is that it counts the frequency of each character inside it. It builds a binary tree using a priority queue, and it combines the least frequent nodes, right? It assigns binary codes and it traverses them in a binary tree. Each node is replaced with this binary code, and then it can be decoded. What all that means is that you can take a look at this resource right here, right there. If you want to read up a little bit on an unordered map, which is going to also help us here in developing this program. It's right there. Right. Uh, so that's the idea, right? So we're gonna use frequency tables. We're gonna be able to access them pretty quickly, and we're gonna group them by hashes. So that's what we're gonna do here for this, right? Now, why the unordered map? Well, because I mean, we don't want the keys to be sorted. There's no need to sort them, right? And then there are also no duplicates in it, which is important. We don't want duplicates. Uh, so that's what the unordered map is. Let me get a binary tree. This image of a binary tree from will make a lot of sense, right? Like if you look at it, that's it right there. Um, so let me throw that in there as well if you guys want to take a look at it. Right, so it's basically tree traversal is what we're going to be doing here for this. Right, so let's get cracking with this file. We're going to say Huffman Compression right there. That's the file. I'm going to put it over here. We'll do that. So that takes care of the make file right there. Uh, right. So do that. So we should start building our frequency table, right? So the first thing we're going to do is we're going to build right. Let's do a couple of imports here. We gotta go. Let's go up here. And let's take IO stream and namespace standard. So we'll take that to put it in there. And then we'll go here. Okay, so we have those. We need an order map. So let's go here. Let's go here and go unordered map. And we want to do then we want to do string. Right. We want to call the class unordered map. Here. There, just like that. Constant string ampersand input like that. Structure Huffman code. We're going here, we're going to do one of those. We'll do jar ch and frequency Huffman. I'm going to do star left. Node star right. That. Okay. The strut keyword in C++ from what I found on Stack Overflow, here's the link. It's going to help us build this binary tree out, basically, right? So what you do is you pass in the characters in the frequency into it. Same thing with they've done it with the mathematical rectangle calculation for area, and they've used it as a oops concept, but I mean, it's basically saying that it works the same way as a class, except there are a few little differences. It hides the implementation details, so you didn't have to do the decorator in the beginning, right? That's, I think, the main thing with it. And it's public by default, and it's very useful for using different kinds of data types that we have over here, right? We have an integer and alphanumeric character. So let me put that there so you have that as well. Can you see it? Okay, it's on the screen, so you have that. Anyways, so when you go over here, you want to do Huffman node like that, and then you want to give the C and whatever of left. Float character frequency table, string input. We could do without. We could just call it into a main if you build an unordered map. How do we comment it out for now? I can just use this directly first. Okay, that's a fine way to do it. just like we did underneath. So we give here, do two of these over here, right there, just like that. We give it directly. Yeah, we don't even need to give it. We can just give it really directly the frequency table. Just like that. All right. We built the frequency table instead of using the Huffman node here and identifying the internet and the characters that we wanted to pass up here, the integers, right? So it's a lot easier if we build the map with just a for loop with the input that we feed into it when we call it into the main function, right? So we can remove this and we can just build out a main function here, like the linear search that we did on the bubble sort that we did. We actually the linear search, right? So we built a function up top right over here like this called linear search, and then we called it inside main. So we wanna use that same. Let's see, there it is right there, right? So that's kind of like what we want to do over here, but we're gonna build out this frequency table, right, with this for loop. It's the char right here is a character, and it's the number of times it's going to appear, right? So if we pass in letters like anything, like we pass in a string, right? Like this is a C++ application, or this is a C++ program, or something like that. It's going to ended up getting passed into this function as a string, and then parsed through it. And then we're looking at the frequency of each letter that's in there with the unique value attached to it. So if you put in Apple, for example, A is in there once, P is twice, PP, and then L, and then E is one frequency. That's the kind of output that we want from this frequency table with our main function that we're going to build out, right? So we want to write it like that. So let's just do int main, just like that, right? Put that in there. String input, right? bananas and apples would be, right? Because we did apples, right? Or apple or whatever. So you can put any kind of string in here that you want with repetition. So you can see that A is 1, 2, 3, 4, 5 times in there. So we want to see an output of A, and we want to see 5 in there. And indexes don't start with 0, unlike Python, right? So we want to do unordered map. We want to give the character and the integer. Like that. It's a table, right? We're going to convert it to build character frequency table. What's it going to take? It's going to take in this variable right here called input, right? So we're going to pass that in there. We'll put in input like that. And what do we want to see out? Now we don't do standard, right? Because we don't have the man. Int main, string input, unordered pair, see out this. Oh. right? That should do it right there. What am I missing? Missing that right there. Move it. Return frequency table, right? Well, for the main function, we do a return zero, like that. Okay, so I think that concludes it. An unordered map, right, of character frequency table build. And the way we want to do it is Huffman Compression. There you go. That's the output right there. The character frequency table. Apple has E1, L, P, A, if you remember the spaces, to A5. You see that? Bananas and apples right there. So that's what this does, right? It like runs it super fast, the executable, and gives us an immediate output. That's the beauty of C++, right? And then, I mean, you can also run it directly from here by hitting this run button right there. So I'll push this up to GitHub so that you guys have access to this. So that's really what it is. So we didn't want to overcomplicate it. I want to keep it really simple. One simple for loop in here, and it's using this unordered map, right? It's building out this character frequency table by taking in two constants of the string and the integer, and then running it over here. A good way to see what is cooking here and this for loop is to run a debugger on it, right? So let's do that really quick so that we can kind of like dig into this a little bit. You see that the unordered map has a character and an input in here that you can see in the debugger. It's in green. And then the ordered unordered map has this class being passed to it, right? And then you can push it over here. Okay, so you can see it underneath over here. So you put bananas input as the input, and then what it does is you see how it has 66 to B assigned to it as it goes through. Now A is 65 and N is 78 and A is 65 again and N is 78. Okay, so it's counting these and assigning independent values to each character inside the string that was passed. And that's really how hash maps internally work, right? So we have this value passed in, and underneath, you see the total map being built out with the frequency table, right? In here, you can see for each one what the internal values are. I don't know if you can see them underneath over here where the mouse is, right? These values are assigned to them. So this loop goes through. Let's undo these and let's push it through, and then we go to the next loop, right? And this is the actual build of the frequency table that we're seeing out, right? So we're done assigning values to it and building its unordered map, right? And then this is going to put it out onto the console, right? So as this code runs, right, you see an output to the console. This one right here puts the pairs out, a colon, and then the second pair out, right? Is the frequency right there. So you're seeing that. Anyways, thank you so much for doing Huffman compressions with me. There is a lot of applications of this, like I went over earlier. And then there's a lot more complex, greedy algorithm applications of this, which we can get into as well. So if you have any questions regarding this, just throw me a message on the Facebook, LinkedIn, YouTube, or Twitch feed, wherever you see this video, and I'll be happy to go over that as well. Thank you so much. I appreciate you joining, and have a nice evening. Thanks. Bye.